the recording has started. Okay, I'm not 100% sure about that. Okay, so that's a good leading into the first thing I want to talk about, because half the class here was not here on Tuesday. How many people were not here on Tuesday? Well, there you go, more than half. Okay, so the first thing you want to do is to remember, where to find my class recording, because that way you can replay the entire lecture on Tuesday, so you know exactly what we went through, the syllabus and everything else. So what you want to do is to remember the YouTube channel. So you go to YouTube. The www part is actually redundant. You can just say youtube.com and then do a slash. Someprofs, SOMEPROFS, as one word. That will bring you to my channel. When you get to my channel, click the videos tab. I'll show you exactly how to do it here. So you go to youtube.com/some, SOMEPROFS, Someprofs, and that will bring you directly to my channel, which I also share with other professors. And it's lightning fast, exactly. So once you get here to my channel, you can click videos, it's a tab. Okay, there we go. All right, so once you click, videos, the tab, it will list the videos, that I have uploaded in a reversed chronological order, which means the most recent one is up at the top. And for those of you who missed the Tuesday class, you can go to, I think Tuesday would be the 21st, so you can go to this one here, 2014. 0121 ARC cisp300, and because of the 0900, that's the one for the first class, because I have a second class at 10:30, so that one is the other one, the 10:30 one. So this is a quick and easy way for you to kind of know what I talked about on Tuesday, about the syllabus and everything else, how to access the class material and so on and so forth. So all of that stuff is already in the video clip. Are there any questions? Now let me just check first, make sure it's not a silent movie, because sometimes I forget to turn on the microphone or choose the wrong microphone to record from. So let me just double check, make sure that you can actually hear the entire thing. There you go. The mic is on. We are not hearing anything. There it is. Do you guys hear anything?
No, but I don't think the computer makes sound, because when you do the volume, doesn't it usually go ding? You know what I mean?
Yeah.
Is your speakers on? Speakers.
It might be using the wrong speaker, because it might be using the speaker on that thing.
There's speakers right behind your drivers and headphones.
Say again? No, it's not that. It's because when I plug in the USB device, it has its own quote unquote speaker, which is not really a speaker. So it might be using the wrong one right now.
The mic's on.
That's the one you want, the US or the Realtek audio.
No, I don't want the Realtek. The Realtek is good for recording, but not for playing.
No, because the other one is the USB. So what you do is you go down to the speaker and right-click it, the one in the corner.
The one in the corner. Here.
Then you click
Oh,
on
okay,
originally,
right there. Okay.
and then you click playback devices, and then you disable the USB one by right-clicking on it and clicking disable.
It's not going to be the same. There we go. Most websites, but you can do it.
I have to do
Now,
that all
when you
the
sign
time.
in, you have to sign in with your W and then 7-digit. Okay.
Make sure you do roll.
No, not yet. Just go pick a seat. Thank you. Well, that shows you how frequently I use Windows, right? I don't even know how to select the speaker, the output device. Thank you so much. Okay, so everything is good. Okay, the Tuesday lecture was recorded with sound. So for people who are adding to this class, you need to watch the video from Tuesday so that you know what the syllabus is about, what I talked about on Tuesday, and how to add yourself to this class if you're not in Moodle at this point. I think most people should be in Moodle at this point because if you're enrolled on roster, you should be in Moodle already. Okay, so I'm not going to waste any time doing that because it's already in the video. So we'll go straight to the material. In fact, we'll go straight to the first homework assignment. For those of you who are new to this class, you're just in time for the first homework assignment. Lucky. It's not going to be hard. Well, to most people. So I'm going to sign in. All of these steps here are already covered in the video, so don't worry about it. You just have to remember where to find the screen recording on Tuesday, and all of this stuff is already covered. All right, so I'm going to go to the class. You should only see one unless you're concurrently enrolled in 2 sections, which I don't think the system allows you to do. We are currently in topic 1, and the first homework assignment is right here. It says, assignment and LibreOffice. It will only show up if after you have acknowledged the syllabus. Okay, so if you have not acknowledged the syllabus, the homework does not show. It does not show the link at all. The acknowledgement of the syllabus is up here. This is the syllabus acknowledgement, so you will have to complete that activity first before you have access to the homework.
Could you click on that? Because I
Which
think
one?
I had problems with it, the syllabus.
The syllabus thing? Okay.
Yeah. Is it only one question?
Yeah, there's only one question.
Okay.
Yeah, there's only one question, but you have to remember to click submit all and finish. Because otherwise, you will still be in progress. You will still be quote unquote, taking
Would
the
I
activity.
go back and look at it again in order to tell whether or not I was finished?
That is correct.
Okay.
If you look again, it should be able to tell you that you are done with it and the score that you're getting with it.
Okay, because I wasn't able to pull up the screen prior to this.
Oh, okay. All right.
It's all.
Okay, so it's all good? Okay, well, so at this point I'm going to click on the homework assignment and show you what a typical homework assignment will look like. It's kind of typical, but it's also atypical in this case because it is really the first homework assignment to set you up for all the other homework assignments that you'll be doing for this class. So the first thing you have to do is to install LibreOffice. How many people already know what LibreOffice is? Okay, we have a few. Okay, how many people know what is Microsoft Office? Okay, the majority. Very good. So think of this as Microsoft Office, but it's open sourced, which means it is free. Okay, it's free to download, free to install. You can install it on as many computers as you want. No problem. Okay. So the first thing you want to do is to install LibreOffice if it is not already installed. For those of you who have it installed already, this step is basically done. There are 2 options. You can choose one or both methods depending on how you plan to do your homework assignment. The first one is to go to LibreOffice.org and install it from their website. This will be quote unquote a permanent setup, a permanent installation, which means LibreOffice can only run on that very same computer where you installed it. It works well if you only use one computer to do your homework. For instance, if you have your laptop computer with you all the time and you plan to do all of your homework assignment on your laptop computer, this would be the perfect way to do it. On the other hand, if you think, well, I might do my homework at home, I might do some of my homework when I'm at work, when I have a break, or I might come to here on campus to do my homework, but I may not be in one of the CIS labs. I might be in the library. I might be on the computer where LibreOffice is not installed. In that case, go to portableapps.com because that way you can install LibreOffice as a portable application. As a portable application, the way you do it is you install it onto a thumb drive. Okay, so you have to have a not really huge. You have to have a thumb drive that can accommodate LibreOffice and the documents that you'll be creating. The nice thing is, no matter where you go, as long as you have your thumb drive, you can plug that thumb drive into any Windows system and be able to use LibreOffice without having to install LibreOffice on all of those computers. Okay, so that's the advantage of using LibreOffice, portable. All the settings, all of your customization will go with the USB device as well. So all the settings will be kind of quote unquote permanent. It will be localized to the LibreOffice to the USB thumb drive. So it's up to you to decide which way you want to do it. You can do it. You can do both ways if you want to. Okay. In this case, LibreOffice will take up to 333 megabytes on the thumb drive, which is not too bad. It will take a long time to install. I have to warn you. If you have a USB stick, that is going to take a long time, because most of the time a USB stick is a very slow device to write to. So the write speed is slow, and that's why it's going to take a while to install it on a USB stick. Question?
How many again? How many will it take up again?
It takes up, according to this, it takes up 333 megabytes
And that's
installed.
For
The portable,
okay.
right. The one that's permanent may take a little bit more. I'm not 100% sure. Yeah. Okay. So are there any questions about LibreOffice Portable? Okay, no question about that. So what we'll do is to continue to read the homework assignment description here. Step 2, you have to customize LibreOffice, which means you have to go to Tools, Options, LibreOffice, and then User Data. The only thing I need you to customize is really just your name. In other words, when I open up a document that you create or that you modify using LibreOffice, I need to see that you are the last person who modified the document. Okay? To do that, you start up LibreOffice first. I think it's installed on this machine. I'm not 100% sure. Let's see. Yep, LibreOffice 4.0 is not the latest one, but it's fine. You start up any application in LibreOffice. It doesn't have to be Writer or Calc. They all share the same user information. So you start it up first, and then you go to Tools, you go to Options, and then the first one, the very first item, is for you to customize your name. So all you have to do is to type your name here. So for me, it's Tag Aoyoung. Click OK, and that's it. I have just customized LibreOffice for the purposes of doing homework assignment in this class. Are we doing okay so far? Okay. So now we continue to read the document, to read the homework assignment description. Step 3, the actual homework assignment. This is very typical of homework assignments in this class. You right-click on the link, you click Save Link As. I will not just click it, because depending on the browser, it might try to open the document, when you click it, and that will make the document read-only, which also makes it impossible for you to modify the document, which is not, which is what you need to do. So I want you to right-click on it and then save the document. Just make sure you remember where you saved the document. In this case, it's to my Downloads folder. Save the document. And once it is saved, you can now click the icon here. I'm using Chrome. I'm sure the other browsers have a slightly different way of doing it, but pretty similar. This would not be good. I do not want you to use Excel to open the document. So don't do it this way. Close right away, don't save anything, do not overwrite the file. So what I need to do now, because it by default is using Excel, I have to go to LibreOffice first, and then from LibreOffice I will click Open, go to my Downloads folder, double click the file that I need to work on, and now we have the document open. Are we still doing okay so far? Okay.
Isn't this still Excel?
Say again?
So you went to LibreOffice and the document came up still as an Excel format?
No, this is actually in LibreOffice. It's a spreadsheet. So
Okay.
it looks like a spreadsheet regardless whether you're opening it in
But just
LibreOffice.
don't do it through Excel.
Right. Do not use Excel to edit the file.
Okay.
Yep. Okay, so now we can move on and read the rest of the description. Yes?
So in general, don't use Microsoft Office?
That is correct.
Okay.
Yep.
Like we won't need it, I guess.
No, not in this class. I mean, you can use you can use Microsoft Office in all of your other classes, but in this class, I need you to use LibreOffice. So right now, we are done with the first step. We are done with the second step. Okay, upload of. Oh, okay. we do need to do this part here. Enter your information in column B next to the questions. So what I'll do is I'm going back to my document here and enter my information in column B. First name, Tak. Last name is Auyung, A-U-Y-U-N-G. Student ID, 1, 2, 3, 4, 5, 6, 7. Save the document first, okay? Before you do anything else, save the document. I would even go as far as closing the document just to make sure that it is ready to be uploaded. So the next step is to use the upload interface. It's not showing here because I logged in as a professor, but when you log in, there will be a way to turn in to submit your file. So you will have to upload the document to Moodle and then say yes, I'm ready to turn it in, and that will be the last step. So are there any questions about those particular steps? Yep.
Do we need to save the file with our name in it, or?
No. Well, the file should have two. There are two parts of the document that should have your name. One is in column B, right?
I'm talking about the file name.
The file name itself, no. The file name itself, you keep the original file name because you're using Moodle to turn it in. So when I get it, I know who turned it in. So I know exactly who should get the points. Yep.
This is probably a stupid question, but when you upload it to Moodle, how do I know it's getting to you?
It will present a link, okay? When everything is successful, it will give you a link where you can actually click the link and download the document back to yourself. That is an indication that I have received the file.
You'll be able to view it from being
right.
on.
Yep.
I think Moodle also sends an email to you.
It does not email to me. It is saved on the server.
The student. I think it's like you'll send yourself an email saying that you've uploaded an assignment.
Oh, it does? Okay. I think that's an option. I may not have enabled that option. If you guys want the confirmation, I can enable that feature. So that way, you get a confirmation email when you have turned it in correctly. So let me see if I can turn on that feature.
Yeah.
Feedback, comment, file, offline. I don't think that's the one.
Submission settings.
Submission types, submission settings down here. Nope. Notifications. But that's only for graders. So I'm not sure. I have not. I think it might have done. It might do it automatically.
I don't know how I did it, but in my English class, I had it sent to my personal email. Everything that happened.
Okay. Let me see if I can do this part. Okay, so I'm going to switch my role to a student, so that way you will see. It's currently hidden because as a student, I have not done the acknowledgement of the syllabus, so I have to do this part first. So I'm gonna say continue the last attempt because I was showing you guys the two options, but I did not actually choose one. So I'm not gonna choose the right one. I, the student, blah blah blah, acknowledge. Okay, click next. Finish all and finish. Submit all and finish. So that means I'm done with the acknowledgement activity. Now I can go back to topic 1. Oh, by the way, there are multiple ways to find your homework assignments. Okay, let me show you how to find your homework assignments. If you look here, we have activities. So under activities, the homework doesn't show up here. I think it has to do with under the calendar. It shows up as assignment and LibreOffice, and I think under upcoming events, it doesn't show up either. I think it has to do with it being conditional. So let's go to topic 1, and it doesn't show up. Maybe it has to do with me not being a student in this class.
Yeah, I don't have.
This is all I could get when I got to.
Even after you complete the
Yeah.
acknowledgement?
Yeah.
Okay,
So I
so
just
something is
printed
not
out all
right.
those.
Okay, something is not right then.
That's what I was asking you earlier.
Okay. So that means the settings is off. Okay, let me change.
Maybe I didn't acknowledge it properly.
Okay, it has to do with the restrict access part. Syllabus acknowledgement must be 100%. I don't have anything else. These are all disabled.
possibly be that I did click finish. And maybe that
Do you see the grayed out activity?
Nope.
can't bring.
Oh, you know what? I know exactly why. It's my fault,
Oh, good.
as usual.
Because it stressed me out when I can ask more questions.
Okay, it's my fault. It's really embarrassing.
No, it's not.
Oh, it is.
People make mistakes.
Oh, it is. Oh, it is. It is visible. I thought I hid it. No, no. This is the course one. Okay, never mind. I need to go to the homework assignment setting.
I went in there.
Sorry about this. I know this is looking all confusing right now. Just hold on 1 second. Okay, here's the homework assignment, and I need to change the homework assignment settings. There we go. And I'll bet you that I made this really stupid mistake. Go to common module. See, I hid it.
good.
No wonder nobody can see it, right? Now it's visible.
Oops.
Yep. As I said, embarrassing. So if I switch back to a student, I should be able to see it too. Oh, it's still hidden. But I think you guys should be able to do it now.
Topic 2.
Hmm?
Good.
I see it. The assignments list topic 1 and topic 3.
Scroll up.
This is topic 1.
I see that, but 2 is not missing, but 3 is showing.
Right, but this is our only assignment right now. So can you see that assignment? Can you click on it?
Yeah, LibreOffice 1.
Yeah.
Yeah,
Can you
it's-
click it?
Yeah.
Okay. So it is okay now.
Yeah.
You should be able to access the homework. I'm sorry about the confusion. Okay. So you can you turn it in? Do you know how to turn it in now?
I think so.
Okay. Alrighty. Phew. Okay. So are there any questions about this part? Okay, it's due in a week. So that means if you have problems turning it in, what do?
Up to you.
Well, you can come to me, or you can also mention it on Tuesday, because it's not due on Tuesday, it's due on Thursday. So if you cannot turn it in for whatever reason, bring it up on Tuesday, and then I'll take a look at the issue and see if there's any problem. All right. Are there any questions? No questions? Okay. So somebody may ask, but why can't I use Microsoft Office? I mean, I have Microsoft Office already installed. I really just want to use whatever software I have installed already. Well, there's one reason why I want you guys to use this method. Let me show you why. So I'm going to reopen the document. The document has changes recorded. Okay, so that means if I go to accept or reject, I can actually see how the document was edited. Okay, including the time, what kind of changes happened at what point, and so on and so forth. Okay, so I want to keep track of all this information for a few purposes. But one of these purposes is, I can at least see how much time you guys have to spend to do a homework assignment. So I can see whether it's too hard, too easy, on the average, how much time people need to get the homework done. I can even see whether people are doing it in one session, like, I'm just going to spend 15 minutes to finish a homework assignment, or break it up and say, I'm going to finish the first part and I'll finish the later part, some other time. And to me, that information is actually useful. I'm hoping that no one is thinking this is an invasion of privacy, because I have no idea what else you're doing at that time. Okay, I just know when a particular cell in the document was changed. That's all I can track. Okay, the application does not take pictures of you while you're doing your homework assignment or anything like that. Okay, so it really is just tracking what changes happened at what time. That's all. Okay, but that's why I need you to use LibreOffice, because when Microsoft Office open the document and save it, it will automatically remove this particular ability. Okay, and any document without this history, I'm not going to grade. So you will need to use LibreOffice to edit your documents. Yep.
So is LibreOffice the same thing as OpenOffice?
Yes, if you have OpenOffice installed, you can use OpenOffice as well. Yep, they are compatible. Yep.
Is it possible that this feature could be off, turned off?
It can be turned off, but if the original document has the feature on, and when I get the document is off, then I'm not going to grade it.
Okay.
So it has to remain as it is specified when you download it. Yep. Now, when you read the homework assignment, there's some additional stuff. I have to return to my normal role to access it. There's some additional, comment, that is actually very important. So let me just continue to read this part here. You must follow these steps exactly, or else you will not receive any credit for this homework assignment. In all future homework assignments, unless otherwise stated, these are the criteria to grade your homework assignment. You have to download the original document from Moodle and then use that file. In other words, you don't want to open up that file and then copy and paste the content into a new document and then use the new document to turn in. Do you guys know what I mean? Okay, so you have to download the document from Moodle and then work with that specific document. You have to use either LibreOffice or OpenOffice. I forgot about OpenOffice altogether, but yes, you can use OpenOffice as well. Your name has to be reflected as the author of the document, and you can confirm it in files, file properties. Do not change any track changes settings. If it does not come with any turned on, just leave it the way it is. If it comes with it turned on, do not turn it off. Documents that do not meet these requirements will not be graded. So the first homework assignment, I would say in this class, maybe around 1/3 of the class, will miss one of these steps. But it's only 5 points out of a whole lot of points in homework assignments, so it's not going to make any major impact. But other homework assignments will start to have more and more points, so you really need to get into the habit of following these steps. Okay, are we doing okay so far with these steps? Well, that's your homework assignment. How long would it take for you to do it? A week? 5 minutes? 2? It depends on whether you have LibreOffice already installed, right? All right, so with that out of the way, we can actually now focus on the topic or the content of topic 1. We'll start with developers and algorithms. And instead of using my own notes to begin with, let me start with, let's see here, the Wikipedia entries. We'll start with algorithm, Wikipedia on algorithms. Right. Are there any classes that you're taking where the professor would say, do not use Wikipedia?
English.
Okay, go ahead.
Problem. I print it out. I like to print out everything so that I can.
That's going to be a long document.
Yeah, it wouldn't let me print this document.
There's no need to print this document. I just want to give you, references. So if you think that my explanation is 2 terms and not sufficient, this is like a full explanation of the term algorithm. Right. In fact, I'm just going to use the first paragraph, to describe what an algorithm is, because the rest is something that we'll actually go through in this class.
Okay.
Yep. So in mathematics and computer science, an algorithm is that's it, okay? This phrase describes what an algorithm is. It's a step-by-step procedure for calculations. That's it, okay? Well, it doesn't quite say what else it can do, or what type of calculation we are talking about. It can include sorting, it can include searching, it can include, a number of things, okay? But nonetheless, if there's something you want a computer to do, the method of getting it done is an algorithm. It's just a method. It's a fancy word for a method. Are there any questions about the term algorithm? Before this class, how many people already know or have at least heard of the term algorithm? Not from the title of this class now. Okay, so where did you heard about the term algorithm?
Bitcoin.
Bitcoin, okay, very good. Star Trek, anyone? Yeah. Well, I would not trust Star Trek, for any type of definition of technical terms like that, because they just They just use whatever sounds good, on screen. Yep, go ahead.
I just have a question.
Yep, go ahead.
On the topic, it said that algorithms differ from methods, and it gave us 2 reasons why. And so now you're saying it is a method. So now
It's a specific. It's okay. I'll put it this way: a method is not necessarily an algorithm, but an algorithm is a method. Okay.
It's a type of method.
It is a very specific type of method. It has to be very precise. It has to be non-ambiguous. So when we tell somebody how to do something, it is usually kind of ambiguous because the other person can kind of clarify and say, well, when you said, tighten up the bolts, how do you want me to tighten up the bolts? Okay, when you have to put the lug nuts back on your wheels. Okay, so we can try to clarify with the other person. But when you're telling a computer how to do something, when was the last time your computer comes back and asks you, can you clarify exactly what you want me to do again or how you want me to do it? Because I didn't quite know how to perform this particular task.
Other than error, no.
Other than error saying that I cannot do it, right? Yep. So exactly, that's the point. Because when you specify an algorithm or when you specify a method and the intended audience is the computer, it has to be non-ambiguous. It has to be complete because the computer does not come back and say, well, you didn't quite tell me how much torque to apply to the lug nut. Okay? It would just do whatever it wants, right? And it will strip your lug nut and you have a problem, at that point. So is that okay? I mean, does that kind of answer your question?
Yes.
Okay. All right. Algorithms are used for calculation, data processing, and automated reasoning, which is really cool. Can someone give me an example of automated reasoning?
AI.
AI, okay. So what is the, can you give me an example of AI application? Recent. Yep.
I was going to say pathfinding in a video game.
Okay, that's one. What about Watson?
Oh.
Does anyone know Watson from IBM?
No.
Okay. No? Okay, now that's something that you might want to look up. I'm not going to spend too much time on it, but it does give you an idea of what computers are capable at this point. Okay, so you just want to look up IBM Watson. Okay, it's basically a computer system that IBM put together that can play Jeopardy, the game.
Oh, okay.
So you have contestant 1 as a human, contestant number 2 as a human, and then contestant number 3 is Watson. And it can interact using voice only. Okay, so you don't have to type the choices to it, and use any type of specific protocol to talk to Watson. It understands natural language, and it can play that game. Okay, the game doesn't have to be doctored or specifically designed for Watson. It just has a huge knowledge base of whatever, right? But that's not the most important part. It knows how to retrieve the right piece of information. So for those of you who do not know what Watson is, I strongly encourage you to find a program. I think Nova did a program on Watson. Okay, because that's kind of where AI is at this point, which is really, really cool. So that's AI. Any other examples of automated reasoning?
Google search.
Google search is kind of automated reasoning, but it's more restricted. It's not really, you're still specifying what words you're looking for, except it's trying its best to prioritize the listing to find the most relevant one first. Okay, and that can be based on how other people do the search and which one they click first. So it can use that also to prioritize what Google thinks is the most relevant link to your search words. Yep, go ahead.
Graphic calculators.
Graphical calculators, to a certain point, yes, they are now kind of, they can do automated reasoning because you can find the closed form of integrations and also derivatives. Whereas, back when I took calculus, There's no calculators. You can bring the calculators. It's not going to be helpful because the calculators can only do calculations. They cannot derive equations. Yep.
Siri?
Siri, that's definitely automated reasoning. What about the Navy's new automated drone? I think it's the X-57B.
Is it automated?
Oh, you guys don't know it, huh? X7 drone. Okay, I think that's the one. No, that's not the one. Not yet. X47. That was okay. I got it wrong. Okay, the X47B, not 57, 47. See, I got one digit right. This is not just a drone, because a lot of drones that we talk about are basically, remotely controlled. Okay, somebody has to be connected to the airplane in real time to navigate, to fly in, to whatnot. This one, sorry?
Sorry, what about the fly-by-wire system?
Well, this is not flown in any way by anyone.
Well, it's like
It's automated.
Will pull back on the stick, and the plane will go where the pilot thinks he wants to go.
Yeah, this one does not need a pilot. It's point and click. Okay, whoever is the commander of the mission just have to drag and drop an icon and say, I want that, removed. And then the plane will take off, complete its mission and come back on its own. Okay, that is where military drones are at this point. This is still X, which means it's experimental, but it also means it's going to be another maybe 5 years at the most before it is actually deployed. Sorry?
Means the CIA probably already has it.
Well, for surveillance purposes, I would not be surprised. They have automated drones, but it's not automated reasoning either. It's just flying a particular path. I think this one has the ability to acquire target automatically. So I would let you guys read the rest of this. But pilots is really a thing of the past. Okay, during a career fair just last year, okay, we were talking about to high school and middle school students and try to find out what they want to do, after they graduate, and try to steer them in the direction of computer science, right? That's my job. And so here comes this girl in high school, and she said, I want to be a pilot, working for the Air Force when I graduate. And I just kind of gave her the wet blanket and say, well, you know what, by the time you graduate, they won't need pilots anymore. How about computer science?
But how do you place a pilot's instinct? How do you place a pilot's instinct?
Well, obviously the automated system would not have the instinct of a pilot, but it can. But since you don't have a person in the airplane, I think it can save easily about 1/5 of the weight of the vehicle, because a lot of that is really life support for the person. And then 2, a lot of maneuvers are impossible for humans because we can only withstand, I think, 10 Gs, when it's negative, when it's positive, and only about 1 when it's negative. And that's why planes have to flip first before they dive, because if you just do it this way, people will get a red out and they just pass out. Yep.
So if I'm understanding you correctly, and when you refer to automated pilot, for example, would that be the same thing as like cruise control?
You can look at it as a very fancy cruise control. Oh, I'm kind of surprised that nobody mentioned this.
Yeah, level 3 automated. Level cars.
I was just kind of surprised that nobody mentioned this. Street view cars. Has anyone seen one of these? Actually, okay.
Tesla. Tesla builds them.
Tesla?
Yep.
I think these are all Priuses, at least with the current generation.
No,
Yeah,
Tesla is also developing it.
Yeah.
Right. I think in 2000, I cannot remember the year. I think it's 2020. In 2020, people are expecting automated navigation in cars that you can buy off a lot. That's only 6 years from now.
I'm pretty sure whoever's authorizing automated cars just authorized a system that lets you press a button on the freeway basically, and you can let go of the wheel, and the car will drive itself along and stay in the lanes and avoid other traffic.
Yep.
So that's where we are now.
That's what we are now, but with Google Cars, they can navigate on highway, in city, it will do everything on its own.
Yeah, I saw the only accident it's had so far in 60-something thousand miles of driving was because the person who has to sit in the driver's seat accidentally touched the wheel and backed into another car.
Oh, so it's the human who's making the mistake, not the automated, system.
So who trusts a computer to drive for them? Like, what if it just like crashes? I'm just old-fashioned. I just want a steering wheel, and I'll just take control of my own life.
Okay. Well, I have an answer to that. Let me answer that question first.
Well, nowadays aren't pilots getting in trouble for relying too heavily on the electronics?
Correct.
Yeah,
Yeah. But even for cars, I would say in another 2-3 years at the most, if it's not already happening right now, you'll be steering by wire. In other words, there's no mechanical linkage from your steering wheel to the steering rack, of your car.
Japan already has that implemented. Japan already has that implemented 6 years ago.
Okay.
Practically.
And it makes sense
10 years
because,
behind.
without that, long axle thing, the manufacturer now has a lot more flexibility as to the placement of the transmission, the engine, and whatnot. So it's already happening. Your life is not in your hands anymore. Even though you might think that,
Wonder how
but
the insurance
because
company feels about that.
I think this is safer than us driving.
Technology-wise,
I totally agree with that.
Saves more money with this.
Yep.
I think the computer's less likely
So
to
it
Go ahead.
also deleted would cause less.
I just want to clarify, it's not the street view car that's driving itself, I think, but they're building an automated car separate of this.
Right,
thing.
correct.
Okay.
But the street view cars are, fully automated.
Are they really?
Absolutely, they are fully automated. The person is only there because of legal requirement.
They
Yeah,
can't even drive them.
it is, but that's really the case. I saw one on highway, when I was driving in Bay Area. So I think this one was driving back to Palo Alto. And it was nighttime, and it was easy to spot, because of the, camera gear and whatnot on the roof. And I was driving right next to it, and I just kind of took a little peek, sideways. And there was a person inside. The person was doing something on the laptop computer. And the car was driving itself.
Wait a second.
Yep.
Okay, so when I was in Seattle, I seen a street view car, I don't think it's the same thing then, because it was like had Google logos all over it and all this stuff. And I was just thinking they were just taping for like Google Maps or something.
That's what they
Well,
Yeah.
they
the
are.
street view is.
Mm-hmm.
But it was driving itself?
It's
Yeah.
yeah. Those cars drive themselves. Yep.
But only in California.
Only in
I'm pretty sure
California?
that Google's self-driving is only here.
Well, I don't know. I seen it in Seattle when I lived there.
Okay.
Well, they have the street view cars there.
But they're not
They have
automated?
normal people driving them.
Okay.
you use
Maybe they
people
just
GPS,
make
but
androids that look
it's
like
useless
people
against off-road.
to do that motion so that people think that there's a person driving it, right?
I guess it would make people feel safer.
Yeah.
The only drawback, it only uses for highways. The only drawback is only good for highways. and
No. It can drive locally too.
Not off-road. Not off-road.
Not off-road, but as far as
I didn't
off-road
see it
as a
on-
Prius can take you.
I know of a house that's completely.
So all the maps is only uploaded for
Yeah.
what is currently happening. If you're on dirt road,
Yep.
good luck. But they're just way too confused where you want to go.
All right. So is that kind of sufficiently describing what an algorithm may be? It can be very simple, okay? Find the maximum number out of 2. Okay, that's really easy, right? Or it can go all the way to automated reasoning, where there's no end, to what automated reasoning can, include. Yep, go ahead. Oh, thank you for the reminder, because I keep forgetting that sort of thing. I need automated reasoning to help me.
We're 10 years behind, aren't we? We're 10 years behind Japan.
We are,
10 years technology behind Japan.
maybe, I don't know. It's hard to say. Go ahead.
Oh, the automated reasoning is Google Glass part of it?
No, Google Glasses is a user interface, device, but what type of software we put on it, I don't quite know yet, but I think there are a lot of new possibilities. Yep, go ahead.
I'm enrolled, but I'm not on here because I was making it.
Yeah, just add your name to the list. Yep. Okay, so let's move ahead, and talk about something else, because there are two main things that I need to talk about. One is what is an algorithm, and the second one is closely related to that, which is what is a software developer. So I'm going to pull up the Wikipedia document first, and then we'll go back to my own document. A software developer is a person concerned with facets of the software development process. That is not a whole lot of help, is there? The work includes researching, designing, implementing, and testing software. So here we have a new term, okay? It seems like software developers are related to software. Great. That doesn't help us much, right? Okay. What exactly is software? I want you guys to help me define what is software.
Computer program.
Okay, program. Okay, go ahead.
I don't know how to say this word, but anyway, it's a processor on how hardware should operate.
I like the second part of your sentence, how something should operate. Okay, that's very good. Go ahead.
It's like an instruction set list for the computer to perform.
Very close. That's almost exactly what it is. Yep, go ahead.
It's a tool. A tool.
It can be a tool, can be game. The software can be game tools, operating system. But I think your definition is spot on. Yep, go ahead.
A bunch of algorithms linked together.
Kind of. Okay, but your definition is really the best. Okay, it's basically instructions to tell the computer the hardware portion of what to do. Okay, so think of it like this. Okay, so how many people here have already worked as an experienced technician in an automotive assembly plant? Nobody. Okay, that makes this a really good example. Okay, you are now hired as a automotive assembly technician. Okay, and you know nothing about automotive assembly, right? So you are the hardware. You are the computer. You are the hardware because you have hands, you have your brain, you have your eyes, you have all the senses that a worker needs in order to assemble automobiles. What are you lacking?
Instructions.
Instructions. Very good. You're lacking the instructions. So when you walk into the automotive plant, what you'll be given with would be, well, amongst other things, would be an instruction manual, right? Step 1, da-da-da-da. Step 2, da-da-da-da. Step 3, if this happens, go to another step, and so on and so forth. That is software. Okay? Software is basically the instruction so that a computer can follow those instructions in order to accomplish something that is useful. Okay?
Say that again.
Okay. The software is basically the instruction that a computer needs in order to perform the operations. It tells the computer how to perform operations. Natively, when you look into a computer, what do you think the processor can do natively? In other words, the lowest level of operations that a computer can perform.
Store and retrieve memory.
Store and retrieve content. Yep.
Wouldn't it just understand binary commands?
It understands only binary commands, but what can those commands do? What can one command do inside the processor? Okay. Go to a certain location to continue execution. Okay. It can add, it can subtract, it can compare, and a few other operations. But that's it. Okay. It doesn't know anything else. It just knows how to do very, very basic calculations. So how can we have browsers, word processors, and so on and so forth, when computers natively can only perform those really, really simple instructions? Software, exactly. So software is basically expressed as a huge, long list of instructions so that the processor, which can only natively perform very simple operations, can end up performing these really complex operations. Okay, are we doing okay so far with that concept? Okay. All right. So with those two terms, kind of out of the way, we'll go ahead and start with the notes that I wrote. And the performance of electronic digital computers have improved dramatically over a short period of about, actually to this point, I would say it's around 70 years and not 50 years. The fundamental concepts of programming actually has not changed. So we trace our way all the way back to the end of World War II, where the first electronic computer was invented to break encryption. Okay, that was its job, is to break encryption. And we look at the theories developed at that point about computers, how computers can operate, and so on and so forth. The theories has not changed at all over these 70 years. Nothing has changed. Okay, the father of computer science is a guy with the name of Alan Turing. Okay, some of you may have heard of his name, and some of you may not, but that's his name, Alan Turing. So if you look up, Alan Turing, that will give you a good explanation of, his contribution to computer science. But basically, the theories that he came up with is still basically the theory that we use today in order to model, how computers operate. What about the hardware portion? Comparing, what we have 70 years ago to the computers that we have today.
Extremely different.
Quite different, right?
Major.
So a lot smaller.
More efficient.
Yep. So we are looking at, let's say, 72 years between the end of World War II and today. Okay. That's about right, right?
More friendly user.
More user-friendly. Yep. Mm-hmm. So 72 years divided divided by 1.5 is what? How many 1.5 years do we have in 72 years?
105.
Okay. Well, that's the same. 72 divided by 2 times 3. So we have 36 times 3, which is 108, right? Okay. So we have 108. No, that cannot be right. I got it reversed. I got it reversed. It has to be a number smaller than 72. So it's let's see, 24 times 2, which is 48. Okay. So there are 18 periods from the end of World War II to about modern day. Okay. So we'll just count it as 48. What is Moore's law saying? Do you know what is Moore's law? M-L-O-O-R-E, Moore's law. What does it say?
That software capabilities are exponential.
It's exponential, very good. But it's not the software, it's the hardware. Okay? For the same price, for the same money, okay, the amount of processing power that you can purchase doubles every 18 months. Okay, so translating that into terms that we really care about is if you go to, let's say, Best Buy and purchase a $300 computer today, okay, and you just say, okay, this is a computer that I purchased for $300 in year 2014 at the beginning. You wait until next year, June or so, okay, maybe July. You spend another $300 and buy another commodity computer from Best Buy. That computer will have about twice the performance of the computer that you buy today. That's what Moore's law is saying. Is that okay? Okay, so every 18 months for the same amount of money, you get twice the processing power, or twice the processing resources. From the end of World War II to now, we have approximately 48 periods of 18 months. So if Moore's law holds true for the entire duration, how much faster are the computers today compared to the computers at the end of World War II for the same amount of money?
2 to the power of 48.
2 to the power of 48. What kind of number are we talking about when we are talking about 2 to the power of 48?
It's just
It's a huge number, okay? It's a huge number. Now, how huge is this number? Well, there's a really quick way to do the approximation so that we can at least get an idea of the magnitude in base 10. 2 to the power of 10 is exactly 1024, and I'll just call that about 1,000. Okay? Would that be okay? Because for approximation purposes, it's close enough. So the question now is, if we are looking at 2 to the power of 48, how many zeros are we looking at when we convert it into a base 10 number? Okay, so let's take a look here. So this is 2 to the power. I think that's about right. Right? 4 times 10 is 40, plus 8 is 48. So that number is approximately 1,000 to the power of 4 times 256. So we are looking at 256, 1, 2, 3, 4. This is the difference, the magnitude change from the end of World War II to today for the same amount of money, at least in theory, according to Moore's law. And I would not be surprised if that really is the case. Because how much do you think is one of those computers that we use, that the British used at the end of World War II for decryption? In today's standard, probably at the cost of at least hundreds of millions. Okay, how much processing power can you buy for $100 million today? That's why I think this number is not over exaggerating. Okay? Great. This is really good news because now we have the possibility to do a lot more with software. Because before the hardware is so slow, you can only do certain things. But now that we have this kind of processing power, the cell phone probably will beat all 10 computers, back then. Okay? With a blink. Okay, there's no comparison anymore in terms of the capability of hardware. But what about software? Hardware is easy to see because it is physical. Okay, you can measure it. You can say, oh, this computer weighs weighs this many pounds. This computer consumes this much electricity. It is this fast, and so on and so forth. So everything that you can see in a computer is hardware. Hardware components are obviously important to the operation of a computer. But the most important part is really not the hardware, it is the software. So right here, the software is the specification of how hardware component should operate. Okay? In a more specific definition, software is the specification of how a processor in a computer should operate, because it only applies to the processor of a computer. Now, you can kind of argue that the GPU, or the graphical processing unit of a computer, has its own software to run. Well, that's actually perfectly correct as well. At the core hardware level, processors can perform certain operations, but really basic ones, like addition, subtraction, and comparison. I would even say that multiplication and divisions are not needed. Because, well, can you do multiplication and division by hand? You can do that, right? Can you do it with, in the form of just addition and subtraction and comparison? Yeah. So that's why, at the very core, just knowing how to do addition and subtraction and comparison is already enough, because we can use those instructions to implement multiplication, division, and all of the other more complex operations. But these operations are useless unless we know how or when to perform which operation and in which order. It is the ordering that is the most important part when you write programs. So software is the component that specifies how operations should be performed in a logical order to accomplish specific tasks. So that's software. It's the instruction manual for computers, for processors. Now this slide talks about where can we find computers. So I asked this question on Tuesday. I think I did. Maybe I did not. How many computers are in this classroom right now?
Oh, phones.
Yep. They're not phones. Remember how I call these things?
Mm-hmm.
They are miniaturized computers pretending to be phones.
Mm-hmm.
Because being a phone is not its primary job anymore. We don't use these as phones most of the time. Yep.
I'd like to think of them as small computers with the phone app.
Yeah, with the phone app, exactly. Okay, because the phone is an app on these things. Yep.
I actually went home and told my husband what you said, and he goes, "That's impossible. I only talk on it." Yeah, he does Facebook, Google Map,
In many
calendar.
exactly. Yep. In many countries, the voice plan is actually more expensive than the data plan. It's just in the United States that it is reversed. Okay, in most countries, especially Asian countries, they would charge you this much money if you just want data. If you want voice, they want more. Yep. If you think about it, if you have a good data plan, you can use Skype, you can use a lot of the other ways to communicate in real time with somebody else, so you don't really need the carrier to give you the voice capabilities, right? Data is really all that you need. Okay. What else? Let's say you're on your way here to school, okay? Unless you're driving a really, really old car, okay, let's say you purchase a Econo box in year 2000, okay? How many computers do you think are on that car already?
Is it not one computer with like 1,000 different software?
No, they have dedicated computers for specific tasks. Okay, go ahead.
Wouldn't there be something for, like, for example, cruise control or
Okay.
like dummy lights? There's got to be a computer to tell them how to turn each one on.
Right? The most important part, go ahead, sorry.
The wiper speed.
Your wiper speed? I think they might have one computer to control several of the auxiliary type of operations. It also depends on the brand of the car, but there's one for sure for ECU. Okay, go ahead.
I was going to say emission control.
Yep. Emission control is the other one. Engine control is one of the most important computers in the car.
Right.
So what does it do? What does engine control do? Timing.
Fuel management.
Fuel management, exactly. So a lot of tuners, would actually change the software for the ECU, so they can, get more power out of the car because the factory may tune the car down, so they can sell the higher end models, right? So some people just remap the whole thing or change the software entirely to something else. What else do you think needs its own dedicated processor? You probably would not want one processor to do ECU and that at the same time.
ABS.
ABS. What is ABS? Anti-lock brake system. Okay, ABS. Okay, how does it work?
It does break little brakes.
Yep, but how does it know that it needs to do that thing?
There's got to be a computer.
When you hydroplane.
When you hydroplane, when you lock up your wheels. Okay, so how does your car know that the wheels are locked up? Does everybody understand what is locking up the wheels of your car?
Yeah.
Okay, so in an emergency situation, if you step really, really hard on the brake pedals, without ABS, what happens is the hydraulic system can exert so much force to the calipers that it can lock your wheels entirely. In other words, your wheels will stop rotating, but your car is sliding nonetheless.
Oh,
Okay.
it's happened.
Okay, it happened, but it's not something that you want to happen, because when your car is sliding like that, there's no steering input anymore. It doesn't matter how you steer, doesn't matter anything, the car will just go in its own direction. Okay, so what anti-lock brakes does is to avoid this from happening. Okay, in other words, if you have ABS implemented correctly, you can still steer the car when you press on the brakes as hard as you possibly can. Okay, And the way it works is the computer monitors the rotation of the wheels all the time. Okay, when the wheel goes from rotation to a sudden stop, that is not possible because of the momentum of the car. Then the computer thinks, oh, okay, this wheel has just locked up. So what it does is it will artificially release some of the pressure so that the wheel will continue to roll again. Okay, and it would do this, and that's why when you step on the brakes really hard with ABS, you feel a pulsing sensation on your feet because it's the mechanism going like that. Has anyone tried and engaged the ABS of your car?
Yeah.
Okay. Has anyone not engaged ABS on your car? Because it's easy to do it. I mean, in an emergency situation, you brake, you step on it, and it just works. Okay, that's its own computer. Do you see that computer in your car? Does it have a user interface other than the brake pedal? Does it have a screen, keyboard, mouse?
Maybe a dummy light.
Dummy light. Yep, they have a dummy light to tell you that you have engaged ABS, or the ABS system has a problem. That's when it lights up to say that, okay, we have a problem here, you might want to have it checked, right? All right.
Dummy lights.
Yep, dummy lights. It's too late lights, right?
Fabulous.
Yep. All right, so that's one application of a computer in a car. What else? Okay, we have ABS here. I use Furbies as an example here too. Some of you know what Furbies are, and some of you probably do not know what a Furby is. What is a Furby?
It's a little toy.
It's a little fuzzy toy.
It's
Little
scary
machine
looking
that
thing.
kind of has digital features and
Yeah, she
talks
wants
to
to another one.
emotions, stuff like that.
It can learn, okay? It can learn words that you say, right? And then you can have two Furbies to talk to each other, and they can teach each other new words, okay?
I think they made it come back.
They make.
They actually will come alive on their own.
Yep. Yep. So those are Furbies, and Furbies, guess what? They have a processor inside, and they have software as well. Okay, it makes sense, right? And today, when I wrote this, it was back in 2006. Okay, so how many years? 8 years have passed. Okay, about 8 years have passed. And in those 8 years, 7 to 8 years, something happened. Apps. Okay? Now, why do we want to talk about apps?
They're replacing everything.
They're replacing everything.
They changed the software.
Yep, they changed the demand of software developers. Okay, they changed that demand because a lot of people can think of, hey, I wish my phone can do blah 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 blah, and most of the time your phone has the hardware to do it already. You have your GPS, you have your camera, you have your microphone, you have your accelerometer. It's portable, it's small, it's relatively light. So you have all the hardware specifications to do a lot of things. It's just missing what? Software. Okay? People can think of all the things that they can do with a cell phone, but it's lacking the software. And that's why there's a boom happening even as we speak right now of apps. Okay? They're running out of people who can write apps.
They're running out of people?
They're running out of experienced software developers for apps. In other words, there are more demands than there's supply. Yep. And that's why a lot of people are willing to pay a lot of money in the Bay Area to learn how to write apps. Some people charge $12,000 for 8-week courses to teach people how to write apps from nothing. This is not assuming that you have a computer science degree already. This is like from ground zero, from nothing. They promise in 8 weeks they will teach you how to write apps. Well, that's a good question.
Is the roll sheet still going
Yeah. Or that has it
Oh, I
stalled
haven't
somewhere.
seen it.
around? Does anybody know?
Okay, who has the row sheet? Okay. Okay, thank you for the reminder. Yep, so that's how popular it is right now at this point.
How much are they paying new app developers?
I have no idea. I have no idea. A lot of app developers are consultants or they're independent. So they just say, okay, if you have an idea, I'll help you implement your program. So they don't really own the program, they don't own the idea, they're really just there to implement the program.
Are some of them home-based, like they work out there?
A lot of them are home-based. Yep, they just work from home. They just go to a Starbucks to meet up with their client, and they go back and do some more coding. So that's something that's new. It just happened in the past, 8 years or so. I don't think iPhone took off. When did iPhones and iPods, take off?
2007.
2007. So it's after 2006. So as I wrote, this note, back in 2006, apps, were not even on the map yet. That's really quick if you think about it. Okay, if apps were not on the map, where was Android? It was non-existent. Maybe there's a company like that, okay, but the product was non-existent at that point. It didn't take long, did it? It did not take long. And Microsoft now has to play catch up. Big time.
Didn't you teach an app class last semester?
Yes, I did.
Okay.
I'm teaching. I was teaching the first part of that class. I'm teaching the second part in this semester. So people will be writing apps in that class. For those of you, I know we are kind of running out of time, so I don't want to read my notes anymore. But for those of you who are kind of thinking, well, I really want to jump on this bandwagon to writing apps and whatnot, but I am still in this class, learning algorithms and whatnot. There's a way you can do it, and I think it's really a cool way to apply what you learn in this class to something that can potentially be very useful. What you do is you go to appinventor.mit.edu. It's really, really cool because it allows you to write apps without learning syntax. How can we do something like that? Well, so let's get started. Well, the one thing they do is they avoid the use of a programming language. Now, how can you specify operations without a programming language? Well, it's completely, okay, let me see. Let me click create here. You need a Google account to get this to work. So let me log in first. I can just load up some of my projects. There we go. Continue. All right. So this is the user interface. It's web-based. You don't even have to install anything on your own computer to use App Inventor. When you write programs, they are called blocks. They're not called programs, they're called blocks. But basically, your program looks like this. Okay, this is an algorithm right here. We have loops, we have conditional statements, and it's a subroutine. In other words, this block here, this chunk of blocks here, is using a lot of concepts that you'll be learning in this class. But it's not in the form of pseudocode or any type of textual programming language. It's in the form of blocks. Now, how do you make programs using these blocks? Well, let me just go to a blank area so I can just quickly show you how to do it. Okay, so you go to built-in, you have control blocks here. You just literally drag and drop the blocks. And if they can get into each other, they just snap. And you have a block inside another block. Okay, so every concept that we talked about in this class, conditional statements, loops, subroutines, parameters, arrays, variables, local variables, and so on and so forth, you can actually apply those concepts in App Inventor. The best part is you might end up with an app that you find useful.
Or sell.
Well, that's a whole different story, right? And to design the interface of the app, you say, okay, I want a button. Well, then you drag a button into the screen. You say, I need a label. Okay, you drag a label into the screen, and so on. Okay. So this is something that you can play with. You know, we are not going to have any homework assignments using App Inventor, okay, not in this class. But as a side, you know, on the side, if you want to apply what you learned in this class and you say, well, tracing is really boring and I know these concepts already and I want to do something with what I have learned so far in this class, this is not a bad way to explore programming. Okay? And we are running out of time. I will see you guys on next Tuesday. Have a nice weekend. And please work on your homework assignment and try to read ahead of me.
Can I write mine on the side like this?
Yeah, that's right.